good evening, guys. Thank you very much for your time. I hope you're well. Thanks for sharing. Maybe an hour, maybe 40 minutes or so. It may come under the 60 minutes, but sharing your time just before, presumably, you're going off taking some kind of festive break, well-earned break, I'm sure, we're looking forward to doing as well. But yeah, we're here to talk about API testing, right? So getting started. So it's kind of a entry-level topic. Now, maybe you've got some experience with Postman or doing these things manually, or maybe doing this with another language. We're going to focus on using Ruby and Cucumber today. I think in the new year, we'll look at an equivalent one doing this with JavaScript as well. So keep your eyes peeled for that session. But yeah, just by way of recapping the agenda. So yeah, we've been working with Ruby for a long time now. We have two versions of a framework that we use. One is Ruby, one is JavaScript. But Cucumber and the use of BDD and capturing requirements in features and scenarios is very much a part of what we do. So yeah, we're real believers in the process of BDD and what that brings to delivery and the testing process. And I think it's great to actually see the use of BDD type scenarios to talk about the testing of APIs as well, right? So for a technical testing concept, when you wrap it in these kind of BDD scenarios, it makes it a much more accessible topic to the wider delivery team as well. It's great for testing transparency. It's great for your testing coverage. But we'll look at that in a second. We're going to talk about how to parameterize your tests as well. So again, using Cucumber tables, passing through arguments. We'll have to look at how we build headers and payloads, of course, right? We're constructing requests to the back end ultimately. And we will cover almost, well, all of the kind of the core API calling methods, really. So certainly get, post, delete, and put, I think we'll be looking at today. And then from a testing point of view, we'll look specifically at how to look at positive scenarios, negative scenarios, focusing on response codes that we get back from a particular service that we're calling, how we deal with exceptions when we're kind of troubleshooting those tests. And then specifically, and this I think is when it becomes quite powerful, is how you start to understand and navigate your way through these JSON responses, right? How you interrogate that JSON response, how you ask it questions, how you determine the values of certain things that you're looking to check, right? And then, of course, in any kind of testing practice, you're almost certainly going to need to be doing this across multiple environments, right? So you have a series of endpoints that you're going to want to test, but you're going to probably prefix that with some kind of environment URL. So we'll look at how we manage that. And then I think, perhaps most importantly is how to keep your code nice and clean, right? So we use a series of helper methods to do this, and they're common to all of the tests that you're going to see tonight. But we'll talk through those as well. Good. All right, that's what we're going to talk about. I'm just going to turn my camera off for the duration. So bear with me 1 second. Cool. Good stuff. All right, so let's just talk a little bit about our setup. Dylan, if I don't appear to be sharing what I appear to be talking about at any point, just raise a hand or let me know. So yeah, just in terms of setup, so we're using TestEvolve Spark right now, our Ruby framework, as we say. Right now, we're kind of focused on the use of Ruby 2.7.4. So I'm very aware that's not the latest, but we'll be going up to 3.1 very soon into the new year. But essentially, to do this, to do any kind of API testing with Ruby and with Cucumber, we're only really looking at 4 key gems or libraries that we're working with here. So, of course, Cucumber, that's going to be the thing that allows us to work with these BDD scenarios. It's going to parse the features and the scenarios and actually become our runner to execute these tests. We use base 64 to do some encoding of user details and tokens to authenticate against the backend, against the application. And then we're actually using REST client, another Ruby gem, Ruby library, to do all the heavy lifting in terms of actually making the API calls to the backend. And then finally, in terms of interrogating the responses that we get back, in terms of making assertions, we're going to be using the JSON gem in order to do that. Okay. We do have some other videos on YouTube. So in terms of setup, we've kind of covered some of these in previous webinars. So we did a webinar 2 weeks ago, which was kind of from zero to hero. So this was more browser-based automation, but it does cover kind of the install of Ruby. So if you're working on a Mac or if you're working on a Windows machine, we have guides and tutorials that will help you to do that. Okay, so yeah, plenty of documentation already on site, of course, on our GitHub page as well. But the application we're going to be working with today is actually the Jira application. So you may or may not be, semi-familiar with some of the APIs that Jira exposed to its users. But it's actually a really good training ground if you're wanting to get into API testing for the first time and you want some accessible APIs. You can create yourself a kind of a Jira sandbox, kind of a free trial evaluation, and then you can start to work with these APIs if you're wanting to start building this kind of stuff into your framework. So highly recommended that you go and check that out because it's nice and easy to work with, and certainly that's what we're going to be looking at today. So I'm going to cut over to the actual code now. So I'm working in RubyMine right now. So this is an IDE from JetBrains, obviously Ruby specific. I've worked with this a long time. So again, you can get evaluation versions of this, but of course you could do this with VS Code, for example, or any other kind of text editor. But this does make life just a little bit easier. So essentially this project, it's composed of kind of one, we're going to look at one environment file. Okay, so we've just got a core environment file where we've got a very small number of details. We've got dummy tokens, we've got a URL, and we've got an email for a user. As far as the core project's going, we have one central feature. That's going to comprise 7 individual scenarios. Now, I've set these up in different ways so you can understand a bit more about the parameterization. So some of these are essentially just very simple 2-step scenarios. Some of them have parameterized arguments that we're passing in using Cucumber example tables, as you can see there. And then others, we use a different, we have a kind of an inline argument here, and we have an inline table here. So it's just to give you a bit of an introduction into the various ways that you can start to inject data to some of your tests. Okay. Now, in terms of the methods themselves, as I say, we're going to look at we'll look at each one of these one by one. So we'll start with this this first one. But I managed to do all of this with a single step definition file as well. So I just have one single API steps step definition file. Okay. So as far as Cucumber frameworks, we have our features and our scenarios, we have our step definitions, and then potentially, and we do in this case, we have kind of a module or a class representation at the lowest level. And then in that class, we have some fundamental helper methods, which we'll start to look at. But let's actually start running some of these tests. So let's look at this first one. Okay, so my feature here, so this is testing the Jira API. Okay. I've just got some notes here about the purpose of the test. So this first scenario, so return all issues in a given Jira project, right? So this is a single test, right? We're using default parameters or arguments within our Ruby methods, which you'll see. And this is focusing on a GET request at the moment. So of course, there's nothing really to see, you know, there's no browser. I'm not going to be opening anything up here, but what I can do is show you the kind of stuff that we can output to the console. For 2 reasons. Firstly, to kind of show you the assertions you're making and the results of those assertions. But secondly, just for informational purposes, if you want to, within certain parts of the test, output information to the console, that can be helpful when you're troubleshooting failing tests. But there you go. Let's run this then. So let's look at our scenario. So we're returning all issues in a project. So very simple 2-step scenario. Given I request all issues for a project, then I can see how many total issues exist, right? So as we're saying, the use of BDD Cucumber scenario is just a really nice way of adding a very readable, digestible language, a business-facing layer, if you like, that's describing the functionality that either you're building, or in this case, you're going to be writing an automated test for. All right, so that test ran, all of these are running in kind of half a second or something like that. And what we have here at the bottom, just some indication that, well, firstly, the test has passed. Well, I have this information in my test that says your API GET request to this URL here. So this is my full URL. Okay, so this is my my sandbox Jira instance. So that's the first part of my URL is in my environment, if you like. So it's extracting that from my environments YAML. Obviously, this is dummy data here, but elsewhere down in this file, I do have realistic data. And then what it's doing, it's concatenating that with an actual endpoint. So the endpoint in this case to run that query against the backend. And again, I get this from the Jira documentation. So it's /REST/API/2, so probably version 2 of the API, /search ? And then it's passing through a JQL, which is Jira query language. And that query is equals project equals TEP1. Okay. So TEP1 in this case is a hard-coded project reference. It's a project that I know to be valid. I can just show you that briefly over here. So here is the actual Jira project in the front end in the browser. So we'll use this to just show how things are being created and deleted. And it's telling me returned this many issues for the project. All right. So my story said, return all of the issues and give me a total for the issues existing in that project. And it's telling me it's returning 124 issues. Okay, so as a test, that was successful. So if we start digging a little deeper now, we'll understand how we actually implement this. Okay, so I'm going to look at the given step first of all. So by clicking through here, it's going to take me to the step definition layer. Okay, I will say at this stage we have a Q&A panel. So if you do have questions along the way, I believe you should be able to use that function. We've got Dylan and Andy from Test Evolve here to kind of try and pick off any questions as they come in. Failing that, if you think of something after the webinar, just find us on social media, on Twitter, Facebook, LinkedIn, or email us at info@testevolve.com. And of course, we'll come back to you afterwards. But yeah, if you do have questions, try and use the Q&A panel. And we had some trouble with that last time, but hopefully it's set up correctly now. All right, so let's look at this step definition. So the implementation for my step, given I request all issues for a project, is made up of one line of code. Okay, so I've got reference here. API is my class, which we'll look at in a second. And then on that class, I've written a method called get all project issues. Okay, and then at here, I'm just declaring an instance variable to actually capture the output of this. And I'm doing that so that I can actually pass this value through to my then step, which is going to come next. All right, because you can see I'm referring to that down here. Okay, so now good, I can see some questions coming in, so I think Dylan's going to try and jump on those and answer them for you. Awesome. So let's look at this method. So get all project issues. Here we go. So let's click into this. So at this stage, I'm now in the kind of the lower level of the framework, if you like. This is a class here, right? This is an API class. It's a combination of our test-specific methods, but also our helper methods, which I'm going to dig into a little deeper shortly. But this was our method that we were just calling from the step definition, right? So get all project issues. Now, the first thing to focus on here, it's got a couple of default arguments or parameters, if you like. Okay, so these are really useful. Okay, so it means I can call this method without needing to call it with specific parameters. I've already got some specified here. And in this case, I was completely happy to use the default project parameter of TEP1, right? That's exactly what I wanted to call. I'm also setting up a default response. So when I call this API and I'll get a response, the response code, I'm expecting that to be a 200. Okay, so when I call this method, I don't need to pass those. It's going to use these default parameters. If I do call that method with values of my own, then they will overwrite these default parameters. Okay. So this is kind of a test-specific method. Now, really, it's doing two things. It's going to start by building out some headers. All right. The second thing we then have is the core request to the backend or to the API. And then finally, we are kind of parsing the response that comes back and trying to extract some meaningful information from that. Now, that just may be for information, or it may be the basis on which we want to raise a bug or not, okay, or raise an assertion, make an interrogation. So we'll look at the headers. So I would call this kind of a helper method, right? Because this is going to be common to all of my requests. So let's just look at that now. These are all in the same class. If I come up here, here is my headers method. And you'll see that this is also the reason why we're using this base 64 gem, this Ruby gem as well. All right, so it's reading in two values. It's reading in the Jira email, the user email from the environments file, and it's also reading in the Jira token, okay? It's concatenating that with a prefix, a basic space prefix, and it's actually encoding them. So it's base 64 encoding this, and I've declared that as a variable here in my method, okay? And then what I'm doing, I'm constructing my headers here, okay? So I declare this as a Ruby instance variable. And this particular header has only got two things in it, right? All I need to talk to the Jira backend, I need an authorization key with a value, and the value I'm going to put in there is the encoded auth that we did in the line above. And then it has a content type of application JSON as well. So that's a very simple header, but it just shows you how we can construct these headers in a JSON object, right? So that's the first thing I do in that method. All right. The second thing I'm then doing is the fundamental call to the backend. So this is comprised of a few things. So if you we have a full endpoint here. So I talked about using the environment URL and then concatenating that with this as well. So we have an environment URL.net/REST/API. So I'm passing through the endpoint that I'm trying to call as I'm calling this method, all right? It's dynamic in the sense that my project value up here is being passed within this endpoint, okay? So that's specific to the project, of course. And then you can see here, the call is where I specify my method. So this is a get method for this particular test. I'm passing through my headers that I declared, and then I'm passing through with a response code key here, the response that I expected that I defined up here. Okay, so fundamental things, we've got the endpoint, the method, the headers, and the response code. So those four things effectively are being passed to this. All right, we'll look at the specifics of the actual method itself, the call, in a second. But the third thing I then do, as I said, I get a response back from that call, okay? And I then start to pick it apart. I start to ask it questions. And in this case, at the end of this particular method, in the response, I'm referring to an attribute or a key or a field, if you like, called total, okay? So I'm just saying, in the response, look for this thing here, convert it to integer. And when I call this method, that's the thing that's being returned to me, okay? So all issues is returning the number that that method returned, okay? So we'll just step back one time more. And what I'm going to do now, so the most, kind of the most complex helper method, if you like, is where we actually make the requests ourselves. So we break this into two. So I'm going to click into response. I'll zoom out slightly. Okay. Now, we've built it out in this way because it also allows us to handle exceptions and errors, okay, because we have this kind of begin rescue block here, right? So whenever we make a call to the back end, so common to all of our API requests that you're going to see tonight, we are using this response method, okay? And fundamentally, this response method within it is calling this request method, okay? The request method is defined here. And this is the kind of the lowest level. This is using the REST client library that we said. And really what it needs is a method. So that's the GET request. It needs a full URL for the API. It needs your headers and a payload if that's relevant. We can specify a timeout parameter here as well. So this response method is making use of that. But the first thing I do here is to establish the full URL of the endpoint that I'm going to be calling. All right. So as we said, that's comprised of two things. It's reading my Jira URL from the environments file, and it's concatenating that with the endpoint that I passed through to this method. Okay. Now, at this point, we are making the request with this request method above it, as we just saw. This rescue block allows us to handle any exceptions. So if I'm expecting a 200, for example, and I end up getting maybe a 400 or 404, this rescue block here will allow me to capture that 400 rather than the test just failing and me having no information as to why it's just failed. With this begin rescue end block, I'm able to capture any unexpected errors and output some of that information to the console. Okay, but essentially what this method will do, if the method is successful, it will return. I've got an assertion at the end that's simply saying raise an error if my response code does not match the specific response code that I passed through. So the first and the fundamental thing we're checking is that the success of the call, right? So if I'm looking for a 200, I get a 200. If I'm testing on a negative basis and I'm testing with bad data, I could be expecting a 400. So this is the kind of the fundamental part on testing this backend, this endpoint, getting a response code that you're expecting as being the first kind of success criteria, if you like. Cool. What I'll do, let's just debug our way through this test, and then, in fact, bear with me. Let's have a look. I'll put a debug point here. We'll put a debug point there, here. We'll just put a couple inside, so we can actually see what's going on when we step through this test. All right, here we go. So same scenario. So I'll debug it this time. Right, so the first thing we do, so we can see the values that are being passed through. So because we're using these default parameters, project and response being set as TEP 1 and 200. If I let it continue one step at a time. So I'm about to actually make the call to the backend now. Okay, so that call has been made. And now I need to pass that JSON response. So I'm going to let it click one more step through. Cool. I've now passed that response. I can see I'm getting something back from Jira here now. I can use my interactive console within RubyMine to actually start to interrogate this a bit more now. So I can put here response. And this is all of the information that I got back from that one GET request to that particular API. Okay, we'll let that continue, and that test is going to pass. So that kind of shows you stepping through some of these methods. Okay, let's have a look at some of the other scenarios. So that's a very simple GET request. Okay, now probably one of the most obvious things we're going to do with Jira is actually create a bug. All right, so this particular example, again, this is a single test. We're using default parameters again, but the key difference this time being, right, this is a post request. Okay, so our scenario says, given I create a bug in the Jira project, then I receive confirmation that it has been created successfully. All right, so let's just run that test. Cool, there we go. It's done in a matter of seconds, 0.69 seconds. Right, my first indication is the stuff that I choose to output to the console. So I can see here that a new bug with a reference of TEP1-901 has been created. And then I've also got this, this assertion statement here, your API post request, as we saw before. So te-sandbox.atlassian.net REST API to issue returned confirmation that this new issue was created successfully. There we go, TEP1-901. So the most obvious way I can show you that is to come back into this project. I do a hard refresh within the browser, and right at the bottom of this list, we are going to find new issue TEP1-901. All right, so I can just click on that. Okay, so here's a new bug in Jira that I've just created through the API. Not much in there, of course, but it's pulling out my, obviously I've authenticated, right? So it's pulling out me as the reporter. There's a summary that I pass through, and there's a description that I pass through. So I'm really not doing any more than that, but we get the confirmation from the API. We can also see it on the front end as well, okay? So let's just look at how this post request differs, all right? So let's step into our creating the bug step. All right, same thing. I'm in the step definition, one line of code. Okay, same kind of thing. I'm declaring an instance variable of an issue here. But this time, rather than get all issues, I've got a new method which says create Jira issue. Okay, it's going to be created in the same API class. So I'm going to click on that. And this is going to look a little different. And this is the first opportunity we get to see how we start building out a payload as well, right? So again, this is a test specific method. I do have a number of kind of default arguments that I'm using. So for the purposes of this test, again, I was completely happy to use these default arguments. So when we saw the summary, test evolve summary, there we go, and test evolve description, this is exactly where those bits of information are coming from. All right. I've also set the status to be, the priority to be highest. In fact, we can see that down here. All right. So all of these values, the way in which I've called this request so far, have been with these default parameters. Now, in terms of process, I'm doing the same thing, right? So I'm starting out building the headers. First of all, my headers are no different. As far as these JIRA tests are concerned, my headers are really just to allow me to authenticate. Okay, so it's doing that base 64 encoding of my my user details along with my JIRA token, all right? Now, what's slightly different about this one from the first one is that we actually need a payload this time, right? So this is how we can define and build out a payload as something that we then send with our API request as well, okay? So this is the payload that you need as a minimum to create a bug within JIRA, and it has to follow this structure. Again, you'd get this from the JIRA documentation. You know, if you're working with your own application, you'd look at maybe your Swagger documentation, you chat with your developers, you'd understand what your headers and what your payloads need to look like, and then you can construct them in this manner. But yeah, key things to me, I need a project, I need a priority, and it's getting all of these values from these default arguments, as you can see. I need a summary, I need a description, and I need an issue type, okay? So my standard issue type for all of these is going to be a bug, but equally, we're talking about JIRA, I could create a story, I could create an epic, for example, but yeah, these values for now are coming from up here. So this is how I build my payload. And then my payload becomes something that I then pass through with this call to the API. So this line here, again, is our core request and response to and from the backend. So I've got a different URL this time. So my environment's still the same. It's getting that from the environments file, but my URL is different this time. My URL is just REST API to issue, okay? The other thing that's different here is I now have a different method, right? I'm calling a post request because I'm creating something. So I pass through my headers here. And now this is how I pass through my payload that I've just defined up here. So I'm just sending that through in JSON format, all right? And then if I'm looking for an error response or response code, they can be passed through here as well. And then after that, the same kind of thing is being done. We are then looking at the response, we're parsing that response, we're extracting something from that. So I'm getting an issue key, and I'm getting that from interrogating the response and asking for the key. And then I'm outputting some console information here. So we can see it's going to give us the new issue key or the new bug reference that's been created with a string created successfully. And that's exactly what you see down here, right? So this is all being done at the time of that request being made, the response being received, and ultimately it being successful, right? So you can see, I think, why kind of logging some of this stuff to the console is very helpful, because you don't see anything else in an API test, of course, right? So the more information you can add to your tests that help you to either troubleshoot if it's going wrong, or just to understand where you are in the process of that test is useful stuff. All right, so that was the creation of a new issue in JIRA. So that's using a post request. The then step there, just to show you, so most of that was done in the given step, right? This was where I did the actual call to the back end. But I've got my BDD scenario says I've got a confirmation step, right? So it says I receive confirmation that it's been created successfully. So I can step into that. And you can see here, I'm simply logging the information. I'm extracting the URL from my test, and I've been passing through this key here, right? So this is really just to allow us to have a slightly more meaningful then step or an assertion step. It's not doing anything other than confirming and playing back some of the stuff we learn from the actual request itself in the given step, okay? But if you are kind of mapping out your BDD, your cucumber scenarios with multiple steps, then you may find yourself on an assertion step like this, needing to just do some output to console with various things you can extract from the test, because really, obviously, the test itself is the request to the back end, and that happens in a single step. But, all right, let's look at some more. So let's look at parameterized versions. So this is a similar thing, right? I'm still creating a bug. But this time I'm going to run the same test effectively, but 4 times over. All right. So we're still using a post request. We're using very, very similar steps, but as I'm sure you can see now, the fundamental difference here is that I'm passing through some arguments pretty much for everything I need to create a bug in Jira. So I need the key of the project. I need to tell Jira which type of issue I want to create. I want to give it a priority, I want to give it a summary, and I want to give it a description. And then what I've done, I've declared 4 examples in a Cucumber examples table underneath that, okay? The other thing I have to do is to convert this from being just a scenario to now being a scenario outline. And that will then allow me to pass through, or to run this test 4 times, but with 4 sets of data. All right. So this is how we can parameterize our tests. So kind of things I've done slightly different. I've got 2 different projects here. So I've got TEP3 on the 4th iteration. I'm keeping them all for bugs right now, but you can see here that each one of these is going to be created with a different priority. Each one of these is going to be created with a different summary, and each one is going to be created with a different description. All right. So I'm going to run at scenario level, and it's going to go through all 4 of those back to back. So let's do that. Cool. So tests have passed. So I've created 4 bugs, right? So we can just see here in the console, got 902, 903, 904, and another project 457. So let's just look in the first project, TEP1. If I come back to the browser, let's just do a hard refresh on the right tab. Again, let's try that again. There we go. So we've got, I think we're just saying, weren't we, 901, 2, and 3. Yeah, we've got 901 here, 902, summary bug high 1, 903, summary bug high 2. So you can see all this information, summary bug high 3. There you go. So that's running exactly the same type of test, but just now starting to look at parameterizing your requests to the back end with the use of Cucumber tables, right? So I could add as many rows as I want to this table. I could change the type. I could create stories. I could create bugs. I could create epics. I could explore all of the priorities. But essentially, my test for all of these, that if I'm supplying valid information via the use of these tables, which I am, then I would expect to get probably, I think it's a 201 in this case. Let's just have a look. When we create, let's create Jira. Let's look at our response code. Yeah, we're looking at a stock response of a 201 for a successful post request to the Jira backend. So yeah, the purposes of showing you that was just to show you how you can start to exploit Cucumber tables to take a stock scenario and start repeating that with multiple data iterations. Cool. All right, let's look at something similar, but we're going to look more of a negative test now. All right, so similar type of thing. It's still a post request, but I'm calling this a parameterized negative test now. All right, so same kind of thing. I'm passing through the same values, right? I've still got the key, the type, the priority, etc. But what I've got here is some bad data, right? So in my priority in the first row, I've got something called bad priority. Well, that doesn't exist in Jira, so that's not going to do anything. And then in the second row here, I have got bad project. All right, well, that's not a project that exists in our test Jira instance. So I'm expecting both of these to fail. I'm also expecting them to fail with particular errors. All right, so I've got something new now that I didn't have before. I've got a particular error response that I'm expecting to get back from Jira. Right now, in the first case, it was a bad priority, right? So I'm expecting this particular error to refer to the priority. And in the second instance, I'm supplying a bad project, right? So I'm looking for an error message that tells me, obviously, that I've supplied a bad project. And as we said, the first indication that we get that a test has either been successful or has failed is the actual response code we get. So in this case, I'm intentionally testing this in a negative way, right? I'm trying to break it. And I'm looking for a 400, right? Now, I know we're just talking about Jira, but of course, when you come to test your own applications, you are going to have these kinds of scenarios to explore. You're going to have these positive and negative scenarios to explore. You're going to have a variety of other response codes. You know, if you're looking at resource conflict, you may be looking at a 409, for example. If you're looking for successful authorization, it may be a 201. If it's unsuccessful authorization, it's going to be a 401. If it's a bad request, it's going to be a 400. If it's to an endpoint that doesn't exist, it's going to be a 404. Now, as your development team are building out these APIs and the way in which you're going to need to test all of these, right? So it's not just these positive tests, but the ability to drive these negative tests as well. And we're still doing this in a parameterized way. Okay, so let's just run this. The two tests I'm looking for, but of course I'm still looking for my tests to pass, right? But they're just negative tests. So my tests have both passed, and really what that means is that I was getting the 400 and I was also getting the error response. Now it's just worth looking at one thing in a bit more detail here. Okay, same thing in the actual step definition itself. Is essentially just one line of code, right? Create Jira issue key. We're using this same method here. So we're building out our payload in exactly the same way. We're calling the API in exactly the same way. But if I debug in the kind of the common response method for now, we will see that because this is a 400, it's going to fall down into this kind of exception loop in this rescue block. So it's worth debugging that just to see how this behaves a little differently. So let's do that. Right, there we go. So this time, and then you can see this is why we need this exception, or sorry, the ability to handle this exception. If we didn't have this rescue block in this helper method that's actually calling the API, our test would fail immediately at this point. But actually, we want a 400 request in this case, right? It's a negative test. I expect to get that. But if I don't include the ability to kind of rescue that error or that exception, all right? So this is a REST client exception with response. If I didn't have this, my test would fail at this point and I wouldn't be able to look at the error messaging, for example, right? So I have this rescue block to allow me to deal with 400 requests or any kind of failing request. If I let it just stick down one more step. Ultimately looking at the responses and the error messages we get back as well. So the success of my test is twofold, effectively. It's the response code, and then in this case, a negative test, it was about checking for the particular error message as well. So let's just remind ourselves. I passed through an error response here, or an error message, if you like, of this particular thing here. And when that test failed with a 400, sorry, when that request failed with a 400, in that response, it also gave me this information. All right, so that became something that I then asserted against. All right, my test themselves passed because I got what I expected. But I think you can understand now the importance of that rescue block to allow you to deal with these. All right, let's look at a put request. So we're going to edit a ticket now. So before we do that, in fact, let's just use one of the bugs, one of the tickets we already have in here. We've got 901, for example. I'm going to edit a ticket now. All right, so we look at an editing of a Jira ticket in this instance with a put request. There we go. So yeah, this is a parameterized positive test using values from our cucumber table with a put request. So any kind of editing is generally going to be using a put request. All right, so we're going to debug. We're going to look at some of the JSON interrogation as we do this as well. Same thing as parameterized, right? But my story now says, given I edit a bug in the Jira project, for the most part, I'm passing through the same information, the project, or sorry, the ticket number. I want to give it a new priority, a new summary, and a new description. So I'm going to edit 3 bits of core information on this particular ticket. And then I'm going to verify that those changes have been applied. Okay, so I'm just going to grab that number again. We said 901. So in my examples table here, I'm going to supply the value of the ticket that I want to edit, 901. And then I'm going to give it a new status. So let's just take a look at 901. So it's currently set with the highest priority. It's set with a summary of test evolve summary, and it's set with a description of test evolve description. So we're going to change those three things. So I'm going to change it from highest to lowest. I'm going to change the summary to be this, and I'm going to change the description to be this. I'm doing all of that with a put request, which we'll look at in a second. In fact, we debug our way through this. Let's have a look. Right, so I'm calling REST API to issue and then the specific issue itself. We can see up here that was a put request. Let's let that continue. Cool. Now, I changed three things there. Now, as far as the Jira backend is concerned, that was three separate requests, which we'll look at in a bit more detail. What we're doing now, we're in the verification stages, right? So I've made the edits to that ticket. So let's just look at that in the front end. Let's do a refresh on 901. There we go. So my summary has been changed to the value I just passed through, new summary for the webinar. My description has been changed. And my priority has been changed from highest to lowest, right? So we can see that the changes have been successful. But what I wanted to show you now is just the ability to look at the response that starts coming back and how you can pinpoint specific parts of the response, okay? So I've parsed the response at this stage, okay? So after having done that put request to the Jira backend, if I come into my interactive console, I can just type in the response here. And this is all of the information I got off the back of making that, that put request on behalf of that particular issue, okay? What you see here are ways that you can then pinpoint specific bits of information. So if I want to get the Jira status from that response, I do it like this, okay? Let's just extract this. So I build out this query in my interactive console that says response, and I'm then targeting key parts of the JSON object. So I'm looking for fields, and then within fields, I'm looking for status, and then within status, I'm looking for name, okay? And when I enter that, I get a status of to do, okay? So you can build these queries in this way. If I took off the name part of that query, there'll be a slightly more high level. This is everything that sits within the status part of that object, if you like. So you can see there that that's where the name was extracted from, name to do, right? So if I built that query again, the full length, there we go. So let's look at some others. So if I want to get the issue type, I'm going to do it in much the same way. So fields issue type, name, and that's going to tell me that it's a bug. Again, if you shorten that query to a slightly higher node, you'd get all of the information that sits within the issue type part of that object. Let's look at description. All right, so this is a slightly longer version that includes some indexes as well. Right, so let's query this. So response, I'm looking in the fields within the description, within the content, the first of those, and then another part of that object that refers to as content, and then text. Okay, so if I enter that, that's how I get to the thing that I'm looking for within that JSON object, that response. Okay, so you can start to explore the responses that you get back to pick out on the things that you think you're looking for, and either, as I say, just for logging information to the console, or to potentially raise an assertion against that. All right, so that's how you can start to explore with Ruby the responses you're getting back. Now, if I just put some more debug points here, I'll let this continue. Let's back to let that one by one. There we're going to go. So it's going to output all of these things. So I've just concatenated a string with the instance variable that I just declared, using these kind of addressing methods to find the information I'm after. All right, so let's just let that play to completion. That test is completed and passed, remembering that was an edit, that was a put request. We saw on the front end the changes that we made. If I now look in here, got some of the outputs, right? So we've got some confirmations here. The JIRA ticket edits were applied. I applied a value of lowest as the status, new summary for the webinar as a summary, new description, right? So that's me outputting the intent of my test. I then have a confirmation that says, yep, we retrieved this successfully from the back end. And then I've got these console outputs just playing back to me the status of certain things that I want to check. Now, for the purposes of this, I just output them to the console, but I could raise an assertion against this. I could raise unless at JIRA status is equal to do, for example, or raise unless at JIRA issue type is equal to bug. So it's just a way of showing you how you can start to pull out bits of information that you are looking for, your expected results from the response, right? So we talked about the response code. That's the first indicator, you know, whether positive or negative, 200 or 400, as the first thing you're looking for, that call to the back end has been successful. But then you're going to want to parse that response, and you're going to want to start to interrogate it, query it, ask it questions, ask it to play back to you things that you're expecting. Now you can do positive assertions, raise unless this thing is equal to something, or this thing equals true. But of course you could do negative assertions as well. Raise if this thing is still set to the old value, right? I just didn't edit. So I just edited the priority from highest to lowest. So I could raise an error if my priority was still set to highest, for example, by extracting that kind of information from the response in this way. So it's just an indication, an introduction as to how you can start to more accurately and very specifically pinpoint certain things for the purposes of your test. Okay, right, let's come back to our API, our feature. Right, and then just finally, we'll look at a delete method as well, right? So there's these are probably the simplest in some ways, because once it's gone, and we don't get anything back from JIRA other than a confirmation to tell you, yes, you did successfully delete that. Now there's two, these are essentially the same test twice, but I'm just showing you one here that is using an inline table. So this isn't a scenario outline because it's not working with examples, but I am still able to pass through a parameterized version of this test by having what we call an inline table just under the step that needs it. And then probably the most simplistic way of doing this with Cucumber, same kind of thing, but I'm just using a kind of in step or an inline argument here within my step definition itself. Okay, so I'll show you how those things physically look different. But let's just let's pick on a ticket from our backlog just to prove to you how this works. Right, let's look at 904 here. Right, we're going to delete 904 and then maybe 903 after that. Right, so my first one, all I've got to supply is my ticket reference 904. That's all I need in order to delete that. Right, we'll run that and then we'll look at the code. So we will play that test. Now the difference here is I'm going to get response code, right? But I'm not going to get a response that I can parse and interrogate, because that ticket has obviously been deleted, right? So really, as I said, I'm just looking for this confirmation. So what we have down here, let's have a look. So there you go, TEP1 904 deleted successfully based upon the expected and actual response codes matching. All right, so we'll look at what that was in a second. Let's just go to our front end, 904, let's do a hard refresh just to prove that that ticket is gone. There you go, bottom of the backlog is now 903. So we can see that that's obviously gone. And then just finally, I'm going to do, we'll do this version. So we'll do 903 this time. All right, let's play that. We'll make sure that's gone as well. And then I'll just show you the difference in the step definition itself. Okay. Cool, and it's doing exactly the same thing. There we go, 903 deleted successfully. Let's just come back to the front end. 903 at the bottom. If I do a hard refresh. Doing the wrong keyboard shortcuts. Let's try that again. No, still not doing it. Let's go old school. There we go, 902 now at the bottom of the backlog. So we just deleted 2, 904, 903, using essentially the same code, but slightly differing step definitions. So an inline table is this thing here, right? So if I step into this step definition, this is what it looks like here. We have to accept, we have to be able to receive the table from our scenario. But I have to be able to call this method here by extracting a value from that table, which means I need to wrap it in this block. So I have to pass through table.hashes.each do. And then the thing that the row of data that I'm passing through, I refer to as value. And then when I make this call to the method itself, to the delete Jira issue method, I refer to it as value bug, okay? And that means it gets to extract this thing here, okay? If I look at the one underneath it, even more simplistic, this is just got some regex here within the step itself, so it will capture anything that is between the words reference space and space from. So if I come back here, all right, so anything between reference space and space from is going to be passed through as a value. We simply refer to that as arg or argument. And that then becomes the thing that I pass to this method here. All right, so just 2 ways of doing essentially the same thing, but that's kind of more Cucumber specific, just showing you how you can start to inject data to your tests there. So we'll do a recap on that in a second, but let's look at the actual delete itself. So I've got a specific test method here for delete Jira issue. I pass through the ticket number as we know. And I'm just saying, unless nothing's being passed through, so kind of defensively coding there. So I do have to pass something. Same thing, build out my headers. That's my authorization. Here's my core response. So the key thing different here is that, as we know, it's going to be a delete request. I pass through my endpoint. So it's REST API 3 issue, and then the issue number. The issue number is being passed through from our argument, as we know. I'm passing through my headers. And I'm passing through a response code. So for a delete, I'm actually looking for a 204 in this case, right? So my expected response is a 204. Now, where am I making that check? Well, I'm making that check within the actual common helper method itself. Okay, so I would be overwriting this 201 with a 204, so that when it actually makes this request here, if it doesn't get that 204 response code, that's the point at which the test would fail, and it would raise this exception at the bottom here. So I guess a delete is by far probably the simplest of these examples, really. Okay, let's just have a quick recap. So we're kind of final 5 minutes or so. So wrapping up. Again, thank you for your time, but hopefully this has just given you a bit of an insight into how you kind of do this stuff specifically with Ruby, with Cucumber. What we see here, I mean, we've covered GET requests just to retrieve information. We've looked at using POST requests to create new entities in the back end. We looked at a failing POST request. So this was an example where we were negatively testing, looking for a 400 response, a bad response, but also looking for a specific error message that the back end gave us. So we looked at some negative tests still being parameterized here. The difference was I parameterized with bad data here and also bad data here. We then looked at parameterizing an edit type of request. So the edit functionality is making use of a put request. As part of doing that, we looked at how you can interrogate the JSON object, the response that comes back to you, either for 2 reasons, really, to pinpoint specific bits of information and to output them to the console, just to give you an indication of how your test is running. But also, of course, probably more importantly, to raise assertions or verifications, checkpoints against particular parts of that response. So, you know, if you are, the edit's the best example of that, because I get a response code to tell me that the request was successful, but also I'm interrogating the response to say, is the new priority set to lowest? is the new description set to the value I expect, is the new summary, okay? So we've got 2 levels of assertion going on in that type of edit test, but we also saw this on the front end in the browser as well, just to confirm. And then finally, we looked at 2 delete requests. So very, very simple, because we're only really working with the response codes in that instance. We're not getting back an object that we can parse and interrogate. But all throughout this feature, we've really been focusing on how you can either have a very simple, clean scenario that makes use of default parameters within a Ruby method within your class, as opposed to having more exposed kind of data permutations within your scenarios. Okay. Yeah, excellent. I'm just going to kind of come back to Dylan if I can. Dylan, if you want to kind of become audible. I think there are some questions coming through. Anything that we want to share or recap on questions, or?
Nothing from me. There was a couple of questions that came in, but I've answered those, and I think they're happy with them. They've said that they're happy with them. So
awesome.
Unless there's any more questions.
Yeah, fantastic. I think if you're an attendee, you didn't ask a question, I think you should have been able to see other questions that were asked and answered, hopefully. If you do have any kind of further questions, please come through to us either on social media, LinkedIn, Twitter, Facebook, or via our info@testevolve.com email address. We'll be only too happy to kind of get back in touch and talk about some of this in more detail. This will be uploaded to our YouTube channel probably tomorrow, so you'll have a full playback capability there as well. So I think really that just kind of leaves me with a final chance to say again, thank you very much for your time. Hopefully that's been helpful. All right. So if you're here because you're starting to explore API testing and API test automation, I should say, not just API testing, because possibly you've done this with Postman, but if you're looking to incorporate automated API testing within a coded framework, hopefully this has given you an indication about how it doesn't need to be the most complex thing in the world, right? We used Ruby, we used Cucumber, we used a REST client, we used a base 64 for encoding, and we use something to pass a response, and that's essentially the building blocks for how we've been doing this. All right, so yeah, thank you very much. Our product, our framework that I've been working with today is available for a 90-day trial. So if you'd like to look at how we do it, this is all kind of incorporated within our framework. So just go to testevolve.com/try. Okay, so it's a fully featured 3-month trial available to anyone that wishes to give that a go. At the bottom there, you can see all the other kind of things that we do as well. So if you're looking at a framework for any desktop, mobile browser automation, we've got you covered. For mobile apps, we've got many, many integrations to other vendors, the likes of BrowserStack, Cobaton, Source Labs, for example, for any of your browser and device testing. If you also have a need to do visual testing, we have our own local version of that, but we also have integrations to Percy and Applitools, for example. So, and a lot of focus for us most recently on accessibility testing and also Lighthouse auditing as well. So if these are things that you do manually right now, and you've been wanting to find a way to incorporate them within your automation strategy, yeah, why not reach out to us, because we can definitely help you to do that, right? Or just sign up for a 90-day trial and go have a play. But thank you very much for your time. I think it just remains for me to say, if you are hopefully taking some kind of festive break yourselves over the next couple of weeks, I hope you have a wonderful time. I hope you and your family are safe and have a happy, healthy new year. And there'll be a lot more of these in the new year. Check out our YouTube channel, check out our events pages or on Eventbrite. But I think almost certainly we'll do a version of this for JavaScript as well. And then we'll be looking at some browser and some mobile specific stuff with JavaScript. So we do support both Ruby and JavaScript and TypeScript as well. Okay, so, and I think we'll leave it there. So thank you very, very much. Reach out if you need anything. And yeah, it's been a pleasure to demonstrate these things to you. Thanks very much.